Out at the serene edge of our solar system, hanging an incredible 30 times farther from the Sun than Earth, is a silent, blue pearl in the unending darkness. This is Neptune. At a glance, it seems to embody peace and tranquility. Located in the remote, dark region of the outer solar system, it gets only 1/1000th of the sunlight that reaches our own world. At this extreme distance, high noon on Neptune would feel like a dim twilight on Earth. It's a solitary sentinel, guarding the final frontier before the eternal emptiness of interstellar space. But that calm is a lie. Hiding beneath that placid blue veil is a nightmare world of unimaginable horrors. A place where the laws of physics are twisted into terrifying new forms. This deep blue marble, named for the Roman god of the sea, conceals an abyss more violent and more bizarre than any ancient myth could conjure. It's a world of pure atmospheric violence, crushing pressures, and secrets that defy our understanding of how a planet should behave. What we've discovered in the deep blue abyss of Neptune will make you question everything you thought you knew about the quiet stillness of space. The story of Neptune's horror begins not with a bang, but with a mathematical ghost story. Before anyone had ever seen it, 19th century astronomers noticed something was wrong with Uranus. Its orbit was off. It wobbled and deviated from its predicted path, almost as if it were being pulled by an invisible, massive hand. This phantom force haunted their calculations, an unseen giant lurking in the darkness. It was a French mathematician, Urbain Le Verrier, who, through painstaking calculations, predicted the exact location of this hidden world. He declared that an eighth planet had to exist at a precise point in the night sky. In 1846, acting on this prediction, astronomer Johann Galle pointed his telescope to that exact spot and, in a single hour, found it. Neptune was discovered not with a lens, but with the tip of a pen. This eerie origin story was a fitting prelude to the strangeness that lay hidden. For decades, it remained just a faint, indistinct dot, a mystery. It wasn't until NASA's Voyager 2 spacecraft flew past in 1989 that the true, terrifying face of Neptune began to emerge from the shadows. And what it showed us was darker and stranger than anyone could have imagined. The first secret Voyager 2 unveiled was the sheer, raw violence of Neptune's atmosphere. Earth has hurricanes, Jupiter has its great red spot, but Neptune has winds that break the sound barrier. Whipped into a frenzy by an unknown engine in its core, Neptune is, by far, the windiest world in our solar system. While Earth's most powerful storms barely reach 250 miles per hour, winds on Neptune scream across the planet at over 1,200 miles per hour. Some estimates push this figure even higher, to a mind-bending 1,300 miles per hour. Imagine a force faster than a fighter jet, not in the thin air of Earth's upper atmosphere, but in the thick, dense cryogenic cold of Neptune's clouds. These aren't just storms. They are planets circling rivers of frozen methane and gas moving at supersonic speeds. They rage in an atmosphere where the average temperature plunges to a bone-shattering minus 370 degrees Fahrenheit. The planet is a paradox of extreme cold and extreme kinetic energy, a symphony of violence played out on a scale that dwarfs our entire world. Why these winds are so powerful remains one of Neptune's most enduring and terrifying mysteries. Voyager 2's cameras focused on a monstrous continent-sized storm churning in Neptune's southern hemisphere. Reminiscent of Jupiter's iconic feature, it was dubbed the Great Dark Spot. It was a vortex so vast it could have swallowed the Earth whole. This cyclone, with winds howling at its edges, was the terrifying poster child for Neptune's chaotic nature. But when the Hubble Space Telescope turned its gaze toward Neptune in 1994, just 5 years later, the Great Dark Spot was gone. It had vanished without a trace. In its place, other, smaller storms have appeared and then faded, like phantoms in the blue abyss. Unlike Jupiter's Great Red Spot, which has been a stable feature for centuries, Neptune's storms are ephemeral, appearing and disappearing in a cosmic blink of an eye. They are transient nightmares, colossal tempests that are born from the planet's internal turmoil only to be swallowed back into the blue chaos from which they came. These phantom storms are a chilling reminder that Neptune's atmosphere is not just violent, but unpredictably so. The secrets of Neptune are just beginning to unfold. We're about to journey deeper, from its phantom storms to an interior where the pressure is so immense it forges diamonds from the air. If you find the terrifying beauty of our cosmos as fascinating as we do, consider subscribing and joining our journey to the darkest corners of space. Now, let's descend back into the abyss. The horrors of Neptune aren't confined to its atmosphere. To truly understand this world, we have to journey deep beneath those beautiful blue clouds. What lies below isn't an ocean in any sense we'd recognize. It's a multi-layered hellscape that defies the very definitions of liquid and solid. Beneath the thin upper atmosphere of hydrogen and helium, the pressure builds to unimaginable levels. Here, we find the first layer of Neptune's ocean, a region thousands of miles deep, rich in water, methane, and ammonia. But this is no calm sea. With temperatures reaching thousands of degrees and pressures hundreds of thousands of times greater than at Earth's sea level, this material exists in a bizarre, supercritical state, a hot, dense fluid that's not quite a liquid and not quite a gas. As we plunge deeper, the pressure continues to mount, reaching millions of times that of Earth. Here, the intense pressure squeezes methane molecules, breaking the bonds between carbon and hydrogen. And this is where one of the most terrifying and captivating processes in the solar system happens, diamond rain. The liberated carbon atoms are crushed together, forming nanodiamonds. These tiny jewels then grow, potentially reaching millions of carats in weight, becoming far larger than anything found on Earth. Heavier than their surroundings, these massive diamonds then slowly rain down through the deep, slushy mantle. This isn't a metaphor. Experiments at facilities like the SLAC National Accelerator Laboratory have replicated these conditions, confirming this astonishing phenomenon is possible. Scientists now believe this diamond rain has a profound effect on the planet. As these glittering crystals sink, they create friction, generating heat and starring the layers of the mantle. This process could be a key component of Neptune's mysterious internal engine. Recent studies from early 2024 suggest this diamond rain may even form at shallower depths than previously thought, giving it even stronger influence on the planet's dynamics. The diamonds may eventually settle into a thick, solid layer around Neptune's rocky, Mars-sized core, a planetary treasure buried under thousands of miles of crushing, supercritical ice. Fueling all this chaos, the supersonic winds, the phantom storms, the diamond rain is Neptune's greatest secret, its internal heat. Neptune is the farthest planet from the Sun, orbiting in the deep freeze of the outer solar system. Logically, it should be an inert, frozen ball of ice and gas, much like its neighbor, Uranus. But it is not. In one of the most baffling discoveries of the Voyager 2 mission, scientists found that Neptune radiates more than 2.6 times the energy it receives from the faint, distant Sun. This is its unseen engine, a furnace at its core that drives its atmospheric violence. While Jupiter's heat comes from gravitational contraction and Saturn's from helium rain, the source of Neptune's intense internal heat remains a mystery. It's a thermal puzzle that sets it apart from its twin, Uranus, which is comparatively placid and radiates very little internal heat. One theory suggests Neptune's thick methane atmosphere acts as a powerful insulator, trapping heat left over from its formation. But the discrepancy between the two ice giants is so vast it continues to stump planetary scientists. This internal furnace is the dark heart of Neptune, the power source for its terrifying surface. This internal dynamism also powers another of Neptune's horrors, its magnetic field. It is a chaotic, mangled mess. Unlike Earth's field, which is neatly aligned with its rotational axis, Neptune's magnetic field is tilted by a staggering 47 degrees. On top of that, the entire field is bizarrely offset from the planet's physical center. One scientist described it by saying, "Imagine taking the Earth, tipping it over diagonally, and then moving its magnetic north pole to Central Europe, and you start to get a sense of what Neptune is like. Recent models suggest this bizarre field isn't generated in the planet's core at all, but in a shallower, convective layer of the electrically conductive, water-rich mantle. The deeper layers, where diamond rain occurs, may remain stable, preventing the formation of a neat, organized field like Earth's. This lopsided, wobbling magnetic bubble creates a bizarre magnetosphere that channels charged particles in unpredictable and violent bursts. As if the planet itself weren't terrifying enough, Neptune's largest moon, Triton, adds its own chapter of cosmic dread. Triton is an alien in its own home. At over 1,600 miles in diameter, it's a substantial world, larger than the dwarf planet Pluto. But its backward orbit is a dead giveaway. Triton is not a native moon. It's a captured object, likely a wanderer from the Kuiper belt that strayed too close and was snared by Neptune's gravity billions of years ago. Its arrival would have been an event of unimaginable violence, disrupting any existing moons and settling into its doomed backward path. Triton's surface is one of the coldest places in the solar system, plunging to around minus 391 degrees Fahrenheit. And yet, against all odds, it is geologically active. When Voyager 2 flew by, it captured one of the most shocking images in planetary science. Dark plumes of nitrogen gas and dust erupting from Triton's icy crust, rising 5 miles into its thin atmosphere. These are cryovolcanoes, ice volcanoes, spewing super-chilled material from below the surface. The existence of these geysers strongly suggests that beneath its frozen rind, Triton may hide a liquid water ocean. Tidal heating from the constant gravitational tug-of-war with Neptune, combined with heat from radioactive decay in its core, could provide just enough warmth to sustain a layer of liquid water. An ocean of water, hidden on a captive moon at the edge of the solar system, raises the tantalizing, if incredibly remote, question about the potential for life. But Triton's story is a tragedy. Its retrograde orbit is inherently unstable. Neptune's gravity is slowly, inexorably pulling it closer. Millions of years from now, Triton will drift too close. It will cross the Roche limit, the point at which the planet's tidal forces will overwhelm the moon's own gravity. Neptune will tear Triton apart, shredding it into a brilliant new ring system, a glittering tombstone for a stolen, dying world. From a distance, Neptune is a tranquil blue orb, but a closer look reveals a world of horrors. A world with winds that break the sound barrier, storms the size of Earth that vanish like ghosts, a deranged magnetic field, and an interior that rains diamonds into a crushing supercritical ocean. It's a planet powered by a mysterious internal fire, a place that actively defies our understanding of how planets are supposed to work. Its largest moon is a captured foreigner, an active ice world on a collision course with its captor. Recent observations from the James Webb Space Telescope have only deepened the mystery. It has provided the clearest view of Neptune's faint, dusty rings in over 30 years and revealed puzzling temperature fluctuations in its atmosphere that defy our seasonal models. Webb has shown us a planet whose stratosphere cooled unexpectedly, only for its south pole to warm dramatically in a short time. It has also given us new views of its strange auroras, shimmering not just at the poles, but in the mid-latitudes as well. Neptune is the final major outpost of our solar system, a world visited only once, for a few fleeting hours, by a probe launched half a century ago. As of early 2026, there are no approved missions to return to this blue abyss. Proposed missions like the Neptune Odyssey, a flagship orbiter that could launch in the 2030s and arrive in the 2040s, remain on the drawing board. Until we return, Neptune will keep its most terrifying secrets hidden, a beautiful, violent, and utterly enigmatic sentinel standing guard over the vast, cold darkness of interstellar space.